Alright, so I've mounted the mechanical, the old school Windex. I want to be able to still keep this on here in the event that any of my electronic autopilot stuff or electronic anemometer fails. So I'm going to try to mount this basically directly above the Windex so that it still has full range freedom of motion and that all the components of this will work. So I have the factory tube. I've already bent it a little bit with my tube bender. So basically I'm going to just bend this 90 degrees and then bend it 90 degrees again at a different angle relative to the first bend anyway, in order to mount this directly above. And then I'll weld a plate to the end of this and then screw it or rivet it to the mast itself.
I'm Anna, and this is Ignacio. We, along with our daughter Elena and our pup Bay, are the new salt selling crew. We are DIYers with a growing appetite for big adventure. Our goal is to DIY and trade our way up to a blue water-worthy boat and set sail on an adventure by sea. We are new to selling and plan to develop our selling skills along the way. Subscribe to stay up to date with our progress and adventures.
Oh, another important note is that I want this bend to be smooth enough so I can still feed the wire through, because ideally none of the wiring is exposed externally and it all just feeds straight through this tube, because the wire outlet through the anemometer is actually like down the middle of this tube from the factory. So I'm gonna try to maintain that. Alright, let's see what that looks like. Alright, so here's the plan. Cut this piece out of some scrap bar stock I had. I'm going to drill, well, there's two options. I hadn't quite decided yet. I'm either going to drill 4 holes in this and screw it, or maybe 2, and screw it into the mast, with just some like countersunk screws. And then I'm going to drill a hole in the side and put a set screw in, so that when I put this anemometer assembly in, I can run a set screw in and just jam it in place. I'm going to go over the mast now and see what option works better. Another alternative is to weld this to a plate and then screw the plate in, but I think the smaller this thing is, the less it'll cause issues with any rigging on the mast. And I like the fact that this is round, so anything, if a halyard does get stuck on it, it's not going to cut into the halyard. I mean, it's smooth all the way around. With this Dynafile, I'll smooth out all the edges. But anyway, I'm gonna walk over there now and see what option is going to be the best.
Spectrum Mobile is a better way to mobile, delivering the fastest overall speeds and the most reliable mobile service coast to coast. And now.
Alright, so now I'm going to take this bushing off, drill my 2 holes and countersink them for the screws that'll hold it in place, and then I'll also drill my hole probably on the bottom for the set screw that'll hold the anemometer pipe, I guess you will, in place. Alright, so we've got this with the countersunk screw holes in it. And we'll just go set this up on the mast and run a center punch through here to punch the 2 holes for our pilots, and then we'll drill them big enough where we can thread these in and they'll still grab. Alright, before we go over there and install this on the mast, I'm going to go ahead and drill for the set screw. And I have a stainless steel screw found in the junk drawer. 832 needs a number 29 bit. Alright, number 29. Alright, so I actually found a little bit shorter screw, so what I've done now is just countersink the entire hole. And as you can see, the screw tip barely sticks out. It'll probably be fine. That gives me a little bit of flexibility because I don't want to have enough meat to get a good bite on the tube, but I don't want to have enough to crush it. So I think that's enough where I'll, even if I do set it all the way down, because this is set down all the way down into its countersink here, it's not going to completely destroy the tube. Alright, so that at least temporarily wraps this up. We got our set screw here, the 2 screws holding this bushing to the mast, and I put this on the bottom so that, you know, it will just naturally shed water. Here's the finished product. You see this is pretty much parallel with the mast. This, I can rotate this piece. There's a set screw right here, so I can actually rotate the anemometer head itself. But if I spin both pieces, you can see that nothing contacts, so it tells me I'm good. I'm kind of curious to see how this will react, like if this the wind speed portion of the anemometer actually like creates some sort of turbulence in the air. But honestly, this is going to be just a backup because I'm going to be relying on the app that I have written to display my wind direction. So this is again just a backup and a quick visual reference if for some reason the tablet is dead or whatever. But I don't want to get rid of it. Just it's important to have. So anyway, something else I've done is I did actually lower this wind vane, the Windex, by what, 2 inches or so, 2.5 inches, just in order to get clearance so that I could use the factory tube. Obviously that was bent, as you guys saw earlier. So anyway, yeah, that wraps up this portion. So next up we will be tinkering with the cylinder. So the boat's kind of a mess right now, but I have the actuated, I call it a cylinder, but the actuator measured up. So this is exactly halfway out, which is going to be our home position. I'm not sure how far back I want to mount it. That's the other reason I got a 150-pound force, because yeah, it may only be 20 pounds or so of force at the end of the tiller, but I'm going to be mounting this pretty far down on the tiller assembly itself. So having that additional force, you know, at the base, just because it doesn't have as much leverage to help it, is going to be beneficial. So I'm going to kind of figure up a mounting solution for this. I think I want to mount it below the tiller, so I'll have a stud sticking out of the tiller that this will come up on, and like a cotter pin or a nut or something will attach it. I do want to be able to quickly remove it, but kind of figure out how I want to do that. I may actually just do a 3D, have a bolt coming in with a nut holding a little 3D printed flange that I can pull out of the way and slide this up and down. And then absolute worst case, something happens that I can't get to it in time, I can just smack this pretty hard and just break that 3D printed piece. So I have some ideas on how I want to handle that, but I think the preliminary idea will probably just be a nut or a wing nut very lightly fastened. And then on this end, I want to have some sort of bracket that I can install and remove the entire cylinder easily, because eventually somewhere on the transom here I'll have a plug for it so that I can remove it, some sort of weatherproof plug, so I can remove it and get the cylinder completely out of here so it's not in the elements. This isn't obviously isn't going to be the long-term solution for a cylinder, because it's not, it's supposedly weather resistant, but it's not. It's just got these little cork gaskets, and it's just poorly sealed. So I may make like a fiberglass case for it or something, but more than likely I'll just find me a good rugged cylinder to use. It's similar dimensions that I can get work that I can modify to fit my existing system. But for the time being, this will work fine. The boat, this isn't going to sit outside all the time. It's going to be inside unless I'm using it. And I could, wrap it in a trash bag or put some sealant on the outside just to help it last. But I don't expect it to be a long-term solution for an actuator. So what I've decided is I was going to try to fabricate some sort of swivel assembly, and I don't think it's necessary. So what I'm going to do is I'm going to build a bracket, and I'll show you kind of what I've drawn up on the whiteboard now. But build a bracket where this actuator will sit on a bolt, which will give me the up and down motion I need to insert and remove it from the bottom of the tiller where my stud is going to be for it to interface, and will also allow me to pivot it and stow it away, still on deck. And then when I want to remove it, I can just pull the bolt out. I'll probably end up using either a bolt, or I'll just get a piece of bar stock and drill a hole for a cotter pin on the bottom, or some sort of simple retainment, maybe a wing nut. I'm not sure yet, but anyway, I just need up and down, and then rotational motion, because as the actuator extends, it's actually going to need some rotation because the angle will change. So it's kind of what I've got. I've got it drawn up on the whiteboard, and then I'm actually going to draft it up in Inventor and then print it out 1-to-1 scale on a sheet of 8.5 by 11, so I can trace it out and then cut it from my aluminum sheets. All right, so here's the side view, the front view, and the top view, and what I'm wanting to do. So I'll have 2 bolt holes that bolt it into the gunnels on the inside of the boat, and then this is where that bolt/pin will go that the actual actuator will rotate on, and then this is just these 2 holes here. So anyway, this is kind of the shape I'm looking for. I'm going to get on Inventor and throw something together. The other thing, I was going to use that piece of angle I had sitting on the bench, but the gunnels are actually slightly tapered, so I'm actually going to have to weld all of these pieces individually, because these will actually be at a slight angle. It'll look something more like this. So there will be a slight angle here. All right, just so y'all can see what I'm talking about here. The boat is, let's see, pretty much level on its trailer here in the shop. And then if I put this on the gunnel, you can see this is about 10 degrees off the vertical. So we do need to account for that. I'm just going to make 3 individual pieces and then weld them up 10 degrees off the vertical on the tab. So all right, so I've got my drawing printed out and cut these out, and then I'm going to use them to trace onto a sheet of aluminum, and then I'll cut the aluminum out and start fabricating this. Alright, so I got my pieces cut out. Turned out alright. It's just hand cutting the plasma on aluminum, so it only gets so good. But anyway, got them all buffed up, cleaned up, pretty close to being weld ready. All I need to do now is wipe them all with acetone before I actually weld. But I wanted to just set it up here and see kind of what this is going to look like. So I do realize now that I've made a slight mistake in that both of these are the same length. One of them really needs to be shorter than the other because of the angle. So what I'll probably end up doing is welding one on top and one on bottom, and that'll get us quite a bit closer, and then I can just grind them back to the same dimension. So by that I mean one of them will be welded here on the edge, and then one of them will be welded on the actual top of the plate. So something like this. If I can see that. Alright, so I have my plate here set up at 10 degrees. So I've set my flange there. And then I've set this piece below and flush up against this back plate. We're about 1/8 of an inch of difference between the two, which I'm tempted to say is acceptable, but I may go ahead and extend the, cut another one a little bit longer just to cover our bases here. Alright, so the new one's going to be 2 inches long. And this is 1 3/4, so we got to add an inch or a 1/4 inch to this length here. Alright, so I got my other one cut. It's a little longer. As you can see, about a 1/4 inch. So now we'll see what this looks like. That's just about perfect. So I guess this one's a little better. Yeah, so that one's just a hair better. So what we'll do now is come in here and shape these to where they're the same. So as you can see, the back one, this one's just a little bit more blunt. So I come around and shape it, and then I'll drill both of them together so that the hole is in the same position relative to the tip, which at that point the tip should be the same distance from the plate, and then we'll go ahead and weld it in. Alright, so what I've done here is just clamped the two together. So now I'll use the smaller one as a guide. It'll be just fine. And I'll come in here and shape all these together so they're uniform, so the tips are even now. I just got to knock off these little corners, and I won't come back too far to knock off these little radiuses on the ends. But anyway, we'll go over to the dyno file and get these straightened up. Alright, so this is it installed on the boat. You can see it rotates fine, and with the cylinder all the way retracted, I can fold it up out of the way, up against the gunnel. Right now it's at 50%, so right there it's out of the way, it's fairly flush. I think this will work just fine. Alright, so I've got my 2 bolts here, this one to go through the tiller, and then this one to go through the actuator arm. So I'm just going to centralize them as best I can and weld them onto the stud, and then we'll go see how it fits. Alright, so I just have a 12-volt power converter, 120 volt to 12 volt, and I'm going to send power to this just manually and see what it does. Alright, so that's max to port. That's boat to port, tiller to starboard, and then this is max boat to starboard, tiller to port. Alright, so that actually gives us a fair amount of angle for the autopilot itself, and we're not expecting huge corrections necessary. But that's really like when we're sailing. I'll look back at some videos, but I don't see me, moving it any further than that, except for when we're tacking. I would like this actuator to run a little faster to get to its points, but this may actually be a good feature that it moves so slow to help tune the autopilot and learn a little bit more about how everything reacts, because it is slow, so there's nothing I can do to speed it up. I can slow it down with pulse width modulation on my solid state relays, but honestly it moves so slow I don't see that being a necessity. It's not necessarily going to overshoot targets being that quick, so I think it'll be alright. Just running it, open or close, no pulse width modulation. I can still continue to use that robot relay board for the time being for testing anywhere. I don't want to use it in when I plan to do some small trips on the boat. But we're just going out for testing and not necessarily relying on the autopilot to be a good option. That's enough to deflect this pretty hard, and it's pulling with no problem, and my rod is staying relatively straight. I mean, there's a little bit of deflection, but not much. So I think that spacer rod will work. Like I said, I need some sort of quick connect idea, but I'll just brainstorm that for a little while and see what I come up with. Well, that about wraps up these two items, the anemometer and the actuator itself. So I'll finish getting the actuator spacer stud welded, and then I'll bolt the aluminum bracket to the gunnel. And then hopefully next time I see you guys, I'll have the mast stepped up in the yard and have the autopilot actually working, so I can move the boat on the trailer, or move the trailer heading to the wind, and we can see the tiller actually correct, and then I'll move the boat back to kind of simulate the boat making that heading change and seeing if the actuator stops. So anyway, we'll see how that goes, but hopefully that'll be here within the next couple days.
If you enjoy our videos, please like, subscribe, and share them with your friends.